Alright, here are solutions for perfect problem 3 for Math 95. We're given this function, f of x equals this mess. In this first problem, we're asked to find f of 2. And probably the hardest part about finding f of 2 is knowing what this notation means. What this notation means is if we think about this function f of a machine, we're putting 2 into the machine. 2 is the input. In other words, instead of putting x in as the input, in which case this would come out, we're putting in 2 as the input. And so what will change is everywhere there's an x, there'll now be a 2. What I'm trying to say is that f of 2 is a lot like f of x, except change all the x's into 2's. So you get something like that. And then that we can simplify. 2 times 2 is 4. And down on the bottom, 2 squared is 4. 7 times 2 is 14. So we get 8 up on the top. And 4 minus 14 is negative 10. Plus 12 is positive 2. So you get 8 halves, which reduces to 4 over 1, which is just equal to 4. In other words, f of 2 equals 4. Put a box around that, maybe. Sure. All right, so that's part A. Part B, find a value of x so that f of x equals 1. So you only need to find one of them, but there are two answers. And the way you find them is you can set up an equation. So what I'm saying is f of x is this thing. F of x is given to me in the problem. F of x is 2x plus 4 divided by x squared minus 7x plus 12. So this thing, this f of x, has got to be equal to 1. So I have an equation that I'm being asked to solve. And I can solve this equation. This is an equation from chapter 7 when we were dealing with rational expressions. The basic idea is we want to multiply both sides of the equation by the least common denominator, which in this case is this x squared minus 7x plus 12. I guess I should write that somewhere. Least common denominator is x squared minus 7x plus 12. Or if you factored that, you'd get x minus 3 times x minus 4. So what that tells us is that 3 and 4 cannot be solutions. We're excluding two values from our eventual solution. Because if x were equal to either 3 or 4, this thing would be equal to 0. And what I would be doing in this step is multiplying both sides by 0. But I'm not. I'm going to multiply both sides by this mess. So what that gives me is 2x plus 4 equals x squared minus 7x plus 12. Maybe times 1. This entire thing times 1. And now I have an equation I have to solve. To solve this quadratic equation, there's an x squared and an x. I need to set it equal to 0. So subtract 2x from both sides. That leaves me with negative 9x over here. And subtract 4 from both sides. That leaves me with positive 8. And so now I have this equation that I can solve if I could factor the left-hand side. The leading coefficient is a 1. So if it factors, it'll factor into this form. And what I need is two numbers that multiply to positive 8 and add to negative 9. There are two such numbers. They're negative 8 and negative 1. Multiply those together, you get positive 8. Add them together, you get negative 9. So what that tells me is that I have something, x minus 8, times something else, x minus 1. And when I multiply those two guys together, I get 0. So either x minus 8 must be 0, or x minus 1 is 0. And these are two linear equations that I can solve. Add 8 to both sides, you get x is 8. Add 1 to both sides, you get x equals 1. Double check to make sure you didn't exclude those solutions. You didn't. Good. These are the answers. I only asked you to find one of them, but there's two of them. Moving on, is 0 in the domain of f of x? Why or why not? Okay, so the domain of f of x is, maybe I'll write that. Domain is all inputs that have a defined output. So it's all numbers that you can put into this machine so that you don't get undefined as the output. Doesn't break the machine. So we can figure out if 0 is in the domain by figuring out if f of 0 is a number or if f of 0 is undefined. We can figure out f of 0 because we know f of x. So f of 0 would be 2 times 0 plus 4 divided by 0 squared minus 7 times 0 plus 12, which is what? 2 times 0 is 0, plus 4 is 4. 0 squared is 0, minus 7 times 0 is 0, so 0 minus 0 is 0, plus 12 gives me 12. So 0 is in the domain. And really the reason why, so 0 is in the domain because this 1/3 right here is a number, as opposed to being undefined. Find the domain of f of x and express your answer in both interval and set builder notation. All right. So to figure out the domain, we have to make sure we don't divide by 0. So we have to make sure that the denominator, this x squared minus 7x plus 12, is not equal to 0. And we can solve that. Actually, I think we already did solve that up here. We can factor that guy out, and it factors to x minus 3 times x minus 4. So we have to make sure x times 3 times x minus 4 is not 0. In other words, we have to make sure x minus 3 isn't 0, and x minus 4 isn't 0. In other words, we have to make sure that x is not 3. Whoa. 3. I guess these should be does not equal, maybe. And x is not 4. So our domain is everything except for 3 and 4, which in interval notation. So actually, before I do interval notation, I'm going to draw a number line. I know it doesn't ask you to draw a number line, but I think it's helpful. So let's see, on my number line, I got 3 over here, and I got 4 over here. And I want all the numbers on this number line, except for 3 and 4. So I don't want this guy, and I don't want this guy. But I want everything else. I want all these numbers. I want these numbers in here, and I want all these numbers here. So in interval notation, I'd say I want everything from negative infinity all the way up to 3. That's this first interval right here. Union, everything between 3 and 4. That's this second interval in here. Union, everything greater than 4, from 4 up to infinity. All this stuff over here. And in set builder notation, I say that's the set of all x such that x does not equal 3 or 4. Interval set builder. All right, moving on. Last part, finally. Find any 3 numbers that are in the range. Make sure to justify why they are in the range. Your answers may vary. Your answer may vary. But really all we have to do is take any 3 numbers, plug them into this, or keep plugging numbers into this function until we get 3 different outputs. So I already know, I figured out above, that f of 2 is equal to 4. That was from right here. F of 2 equals 4. So what that tells me is that 4 must be in my range, not in my domain. Have I figured out any others? I figured out f of 0, so maybe I'll use that one. F of 0 is equal to 1/3. So 1/3 is in the range. I don't know if I've calculated any other ones, but I could. My third one, what do I want to use? I don't know. Use whatever you want. Maybe f of 1. 1's an easy number to deal with. What I would do is I would plug that into my function. It's 2 times x, but x is 1 now, plus 4. All right, that's 2x plus 4 divided by x squared minus 7x plus 12. So that gets divided by x squared plus 7x plus 12. So 2 times 1 is 2, plus 4 is 6. 1 plus 7 plus 12 is 20. And that reduces to 3/10. So 3/10 is in my range also. So the three numbers that I found in the range are 3/10, 1/3, and 4. But your answers may vary if you put in other numbers, things other than 0, 1, and 2, into the function. But that gives you an idea how to find any, and I guess that's the last part of this perfect problem.